And welcome to part 2 of our 4-6 lesson video, graphing those other trig functions. We've got 2 left to do today, and they are the graphs of our reciprocals, cosecant and secant. And it says here the graph of the 2 remaining trig functions can be obtained from the graphs of sine and cos using the reciprocal identities. Remember, cosecant is just sine flipped over, secant is just cos flipped over. Now, we're not just going to flip over the graphs, but we use the graphs of sine and cos to come up with the graphs of secant and cosecant. Blah, 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 blah. I'm not going to read the rest of that. Here we go. To sketch the graph of a secant or a cosecant function, first make a sketch of the reciprocal. For instance, to sketch the graph of cosecant, first sketch the graph of the sine wave. Then take the reciprocals of the y-coordinates to obtain, well, I'm going to blow this up here a little bit so you can see a little better. So if I ask you to graph cosecant, first thing you'll do is graph sine. Here's our sine wave. We start at the origin. We end at 2 pi. We've got an x-intercept in the middle. Positive sign begins by going to a peak and then a valley. Once you've graphed the sine wave, notice that this x-intercept turns into a vertical asymptote. This x-intercept also turns into a vertical asymptote. Anywhere that the sine wave crosses the x-axis will be a vertical asymptote for cosecant. And then if we've got this peak, this hill, that's going to be our vertex, sort of this parabola opening up. And then here we've got a valley. We've got there a parabola opening down. It stays in between the vertical asymptotes. Same thing here. We've got this valley, so I got a vertex there, and that parabola opens down. And a very, very similar thing is going to happen with secant, but for that we're going to graph a cos wave. So here the light gray, here's cos. It starts at a peak, it ends at a peak, it has a valley in the middle, and then we have our x-intercepts between those peaks and valleys. So we graph a cos wave, we find the x-intercepts of the cos wave, and those become our vertical asymptotes. Here's another one over here. X-intercept becomes a vertical asymptote. And then from the hills, we have parabolas opening up. From the valleys, we have parabolas opening down. And there is our secant graph. Well, the secant graph is just the darker inked parabolas. That light cos wave in there, we just use that to come up with our secant graph. So let's try this one out. Holy cow, this one looks like it's got a lot going on in it. It says sketch the graph of y equals 2 cosecant quantity x plus pi over 4. And it said for the solution, first we begin by sketching the graph of this. Notice the only thing they changed is the trig function. Up here it is cosecant. The one we're going to graph, they just changed that cosecant to sine. Everything else is identical. So we're all pretty good at graphing sine waves. So let's see here. Let's start with our amplitude. Amplitude is 2. Now, I'm not going to go all the way to the top of my axis here. I'm just going to go about halfway. So there's 2. Make this about -2. Period for sine and cos, it's 2 pi divided by the number in front of x, but there's a 1 there, so the period is 2 pi. And let's see, we do have a shift here. It looks like that's going to be a shift to the left, pi over 4 units. Oops. So let me get these a little more out of the way. Get over there. So here, I'm going to go out this far, call this 2 pi. And I'm going to eyeball that, cut it in half. That's about 1 pi. And then I'm going to mark that as a half and 3 halves. Now I'm going to mark them with a different color ink. This will be my 1/4, 3/4, 5/4, 7/4. And I'm going to do that pretty similar over here on the other side. Just eyeballing that. And then this would be -pi. Okay, that might be enough to get us started. So let's see now. We're going to do a sine wave. I'll switch to black ink. Sine usually starts at the origin, but we're shifted to the left. So it's going to start here instead of at the origin. It would usually end at 2 pi, but I'm going to bump that 1/4 pi to the left. And sine usually crosses at pi, but we're going to bump that to the left here to 3/4 pi. So there's our 3 x-intercepts. And of course, sine, if it's positive, is going to start by going to a peak. Right in between these two x-intercepts, that would be here at 1/4 pi, we're going to have a peak. And then in between these two x-intercepts, we're going to have a valley. Right about there. Come on. There we go. And if I connect those dots now, I'm going to use, well, I can just do this in my ink here, and then I can move it with my mimeopad. So the sine wave that we're looking at kind of looks like this. And let's do one more cycle over here. You know, from here to here, yeah, negative 1 1/4 pi. We'll have a loop of that underneath. Okay, now wherever this graph hit the x-axis becomes a vertical asymptote. And I'm going to make the, whoa, I guess that won't work. Nope. Okay, bam. So right here, I'll do this one first. Come on. There we go. And I can do this. Copy, paste. Here's another one. So that one will go here at negative 1 1/4 pi. And I'm going to put another one over here at positive 3/4. And then another one over here at 1 3/4. So there's the vertical asymptotes. And now I'm going to switch to, I guess, blue ink, and I'll do my parabolas. Here from this peak, we have a parabola opening up. Here from this valley, we have a parabola opening down, and another one over here. Now I, because of my software, can just take this, the sine wave, and I'm just going to throw that in the garbage, because we only needed it to get our graph of cosecant, and there, those blue parabolas are the graph of our cosecant function. 2 cosecant of x plus 1/4 pi. Okay, now for secant, we're going to graph a cos wave. And this is nice, it hasn't been shifted at all. So for this one, period equals 2 pi divided by the number in front of x, that's 2. So our period is pi. Oop, and I should note here, let me move this up. We are graphing, we're going to start by graphing y equals the cos of 2x. So we figured out the period is pi, our amplitude is 1. So we're going to go here from 1 to negative 1. And we're just going to go out. Let me move the, get out of there. Come on. That'll help a little bit. Get, there we go. So I'm going to come out this far, and that'll be one period. We'll make this positive pi, and I'm just going to eyeball cut it in half. There's pi over 2, and then here's my quarters. And let's do the same thing to the left. I'll make about this far negative pi over 2, and we'll put our marks in the middle. There we go. So let's do a cos wave. I'll switch to red ink. Or no, I'll make this one black ink. Cos, positive cos starts at a peak. So here on the y-axis, we're at height of 1. 1 pi later, we're done, and we're at another hill. So there's our 2 peaks. In between the peaks is a valley. That'll be right at half pi. Now, in between the peak and the valley, we're going to have x-intercepts. So that's going to be here at 1/4 pi and at 3/4 pi. So let me draw this one in. Look a little something like that. And let's do another cycle to the left. So if we're at the y-axis, we'll jump pi to the left. That'll be another cycle. We'll end on another peak. Right in the middle at negative 1/2, we will have a valley. And in between the peaks and the valleys at negative 3/4 and 1/4, we'll have x-intercepts. So there's another cycle. Now I can take these vertical asymptotes. That one didn't thicken up. There we go. I'm going to put this one right on this x-intercept. Got another one over here. That'll go on this x-intercept. And one here at 1/4 pi. And another one at 3/4 pi. Okay, last step. Let's draw our parabolas. I'll go to red ink for this one. So here's a, whoa. Here's a peak. That's supposed to be red. There we go. Here's a peak. We have a parabola opening up. Stay in between the vertical asymptotes. Negative 1/2 pi, we got a valley. So we're going to have a parabola opening down. Right on the y-axis, we have a dot there, a hill, so we're going to do a parabola up, half pi positive, parabola down. I think that's good enough. I can take my Cos waves and throw them into garbage. Their job is done. And there's our parabola graphs of secant of 2x. All right. Here's a few to try on your own. There's 3 of them. So pause the video, try those, and then start it back up and see if you got them right. Did you pause the video? I don't think you paused the video. Okay, let me just make this one bigger. Move it down here a little bit. There we go. Okay, so negative 1/2 secant x. So we're going to graph negative 1/2 cos of x. Okay, negative's important, and in this case, the half is important. That's our amplitude. So we're going to go from a half to negative a half on the y-axis. And the period is 2 pi divided by the number in front of x, so that's just a 1, so that our period is 2 pi. So I'm going to go 2 pi over this way, and I'm going to eyeball it, cut that in half as 1 pi, and this will be 1/2 and 3/2. And let's do the same thing to the left. Let's go here to negative 2 pi. And then in the middle there would be negative pi with negative 3/2 and negative a half pi. All right, let's get ready to graph a couple cos waves. And because it's negative cos, remember negative cos is going to start down deep in a valley. So we're going to start here at negative a half on the y-axis, and then the period later at 2 pi, we're in another valley. So there's our 2 valleys. In between the valleys there must be a peak. That peak is going to be above pi, up here at 1/2. We will cross the x-axis in between the peaks and the valleys. So it'll look a little something like this. And let's do another cycle to the left of the y-axis. So from 0, we'll jump the cycle to negative 2 pi. There's our valleys. We're going to have a peak at negative pi, up there at 1/2. Cross the x-axis in between the peaks and the valleys. So that'll look something like this. And we're now ready to drop our vertical asymptotes. We'll have one here at negative 3/2 pi. Another one at negative half pi. Got one here at positive half pi, and another one at 3/2 pi. Now from our hills and our valleys, we can draw our parabolas. Peak here at negative pi means a parabola opening up. Valley here on the y-axis at negative a half, we will have a parabola opening down. And a peak above pi tells us a parabola opening up. And now I can throw in the garbage my cos waves that got us here. And there we go. Now down below we've got cosecant of x over 3 or cosecant of 1/3 x. And can I do, nope. There we go. So this one, I'm going to rewrite it as cosecant 1/3 x. And actually I'm going to write it like this because to graph cosecant we're going to graph sine of 1/3 x. So let's see, amplitude is 1, from 1 to negative 1. And then the period is 2 pi divided by the number in front of x, which is a 1/3. To divide that, bring the fraction up and flip it. So that'll be 3/1 times 2 pi is 6 pi. The period equals 6 pi. So let's see, we're going to start here at the origin. I'm going to jump this way. We'll call that 6 pi. And then we'll eyeball that, cut it in half. Half of 6 is 3 pi. And I'm just going to mark here, this would be 3/2 and 5/2 pi. Let's do the same thing symmetrically to the left of the y-axis. So make this negative 6, negative 3 pi, and then negative 3/2 and negative 5/2. Okay, I'm going to switch to red ink. Let's do some dots for the sine wave. Okay, sine, it's going to start at the origin. 6 pi later, the cycle's over, and we're back on the x-axis. And we're going to cross in the middle at 3 pi. And because it is positive sine, we'll start by first going to a peak, and then we'll cross at 3 pi and go down to a valley. So here is one cycle of our sine wave. And we're going to do the same thing to the left of the y-axis. So the period is 6 pi. We'll start here at negative 6, and then we'll end at the origin. And of course, we'll cross at negative 3 pi in the middle. And if we're starting at negative 6 pi, it's positive sign, so we're first going to go to a peak, and we'll cross our x-axis and then go to a valley, and that will take us right back to the origin at the end of this cycle. Okay, time to drop some asymptotes in the proper spots. Anywhere we have an x-intercept, like here at negative 6 pi. Got one here at negative 3 pi. Got one right on the y-axis, don't forget that one. And then we got one here at 3 pi, and I'm going to have to copy that. There, whoa, where'd you go? Paste, there we go. And we got a VA there at 6 pi. So I'm going to switch to black ink. Here we have, a peak. So this will become a parabola opening up. Here is a valley, parabola opening down. 3/2 pi, we have a parabola up. At 5/2 pi, parabola down. And now I can take the sine wave and throw it in the garbage. So there are 4 cycles of our graph cosecant of 1/3 x. And I think we got one more to go. Oops. There we go. If you haven't seen this one, pause the video and try her out. Or you might have seen it in your notes and just finished it up. So this is negative 2 secant 4x. So we're going to start by graphing negative 2 cos of 4x. All right, the negative tells us our cos will start in a valley. Our 2 is our amplitude, so I'm going to do here 2 to negative 2. And let's find the period. The period is 2 pi. Divide by the number in front of x, that's a 4. So 2 pi over 4 or pi over 2. Our cycle is just a little tiny half pi. So what I'm going to do is come about this far, call that half pi, that'll be a full cycle. And let's cut it in half. How do you cut a fraction in half? Double that denominator. So this would be pi over 4. And then this one here, cut it in half again, that'd be pi over 8. And let's figure out this one, 1/8, 2/8. This would be 3/8, and then 4/8, which reduces to a half. So this is 3 pi over 8. And we'll see the similar numbers here to the left. Pi over 2, pi over 4. Now I'm just going to mark these but not label them. 1/8 and 3/8. Okay. I think we're ready to graph our cos function. Let me switch to red ink. And again, we already said it's negative cos, so we will be starting in a valley, down here at negative 2 on the y-axis. And the period is pi over 2, so when we get to pi over 2, the cycle is over. And we've got our 2 valleys. That means there will be a peak right above pi over 4. And we'll cross at 1/8 and 3/8 on the x-axis. So it looks like that. And we'll see something very similar here to the left of the y-axis. If we're at 0 and we jump the cycle, here we are at another ending valley. We will have a peak at positive 1/4 pi at a height of 2, and we'll cross the x-axis at negative 3/8 and negative 1/8. So there's another cycle of our negative 2 cos of 4x. Okay, time for the asymptotes. We'll put one right here at negative 3/8. Oops, there we go. Here's another one at negative 1/8, positive 1/8, and positive 3/8. So now it's just time to draw our parabolas. I'll switch to black ink. Here we have a peak at negative 1/4 pi, parabola up. Here's a peak right on the y-axis, or a valley right on the y-axis, parabola opening down. And then at 1/4 pi, we have parabola up. And there's 3 cycles. That'll be good enough. And I can get rid of the cos wave because its job is finished. And there we go, 3 cycles of negative 2 secant of 4x. Assignment is not on WebAssign. So here, page 506, check out these problems. 1 through 6, that's all. That might be like a matching, if I remember correctly. That might be match the function to the graph. So enjoy those problems, and I will see you in class.